Hello Year 9, this is lesson 2 in the GCSE waves topic. Today we're going to be looking at the properties of waves. That's your title, the required pages and the textbook are shown above. Today we'll be looking at what is meant by the terms amplitude, wavelength and frequency of a wave, what the time period of a wave is and how it's related to frequency. This next slide needs to go into your notes, so you can either print it off or handwrite it. I really don't mind which. Okay, starting off with the diagram that you see on the right hand side, you need to have, you're drawing it, a straight line which is representing the rest position, so a string which isn't being moved at all if you prefer. Then you've got your nice wave here, you've got trough, which is the bottom of the wave here, and the top of the wave is called a peak. And the distance between a peak and the rest position, or the trough and the rest position, is what's called the amplitude of a wave. It's the maximum distance that the wave or the string, if we're talking about waves on the string, is from the rest position. You can either add these next labels to your original diagram or redraw it. I've done here to avoid confusion. These lines here represent something called a wavelength. Now the wavelength is the distance between two corresponding points on a wave and is measured in meters. Okay, so an easy wavelength to draw will be the distance between two peaks or the distance between two troughs. However, you may see it drawn whereby you've got a point here on the rest position, follow it round till it hits the rest position with a wave on the way up again. That's also a wavelength. The third term that we need to be familiar with is something called the frequency. This is how many waves are made or pass through a point every second, and the frequency is measured in hertz. So a couple of problems for you to have a think about. You don't need to write these down or anything. So A, we've got to find the frequency of a wave if 100 waves pass through a point in 20 seconds. So 100 waves pass through in 20 seconds. That means that 5 waves are made or pass through a point in 1 second. So the frequency F is 5 hertz. Part B is exactly the same. The frequency is the number of waves divided by the time. So 50,000 divided by 5, which gives you 10,000. But notice this time it wants the answer in kilohertz. So 1 kilohertz is 1,000 hertz. So the answer would be 10 kilohertz. Okay, these are slightly more challenging. Have a look at the diagram here, and in the back of your books or wherever, write down what you think the missing values are. Okay, solutions then. Part A, you've got to work out how long it's taken to make that picture, as it were. Well, the frequency of the wave is 2 hertz, which means 2 waves are made every second. We've got 2 waves in the picture, so the time taken must have been 1 second. Here, you've got to work out the number of waves. Well, the frequency tells us how many waves are made each second, 2. It's on for 5 seconds, 5 times 2, 10. 10 waves are made. Here you've got to work out the frequency. Frequency is the number of waves made in 1 second. Well, 1 wave is made in 2 seconds, so only half a wave is made in 1 second. Part D, same as the top one. You've got 3 waves made every second. We've produced 6 waves in total, so it must have taken 2 seconds to do that. I hope you did well on that. Okay, this next slide again needs to be copied down into your notes or printed off and stuck in. It's entitled A Time Period of a Wave. So the time period of a wave is simply the time it takes to produce 1 complete wave, and that's best illustrated with this little diagram here. So along the bottom here is units of time, these are seconds. If we start at this point here and we follow it around until we've got 1 complete wave or vibration, that's only half because we're on the way down still here. Well, that's 1. Can you see it's taken 0.4 seconds to make 1 complete wave? 0.4 seconds to make 1 complete wave means that the time period is 0.4 seconds. Now, in addition to that, you need to be able to calculate time periods or frequencies using a formula that you will be given in the exam. And the formula is this, and if you're in the habit of highlighting these formula in your notes, then please do so. It says that frequency is equal to 1 divided by the time period. You may see it as time period equals 1 divided by frequency. It means exactly the same thing. So if we try and calculate the frequency of the wave on the right hand side, then it's 1 divided by, our time period is 0.4. 1 divided by 0.4 gives us 2.5 Hertz. Now, if you're unsure as to whether that's right or not, just consider this. The frequency of a wave is the number of waves made in 1 second. So let's use the diagram to count up how many waves are made in 1 second. So there's 1. There's 2, we haven't finished yet. And that is 2.5 waves made in 1 second. So that's confirmed. The frequency is 2.5 Hertz, 2.5 Hertz. Okay, so looking back at our objectives, you need to know what the amplitude of a wave is. So the amplitude is the maximum displacement or distance that an object moves from its rest position. Okay. The wavelength of a wave is the distance between two identical consecutive points on a wave, e.g. the distance between one peak and another, or one trough and another. The frequency of a wave is the number of waves that are made in 1 second, or the number of waves passing a point in 1 second, and is measured in Hertz. And lastly, the time period of a wave is the time taken to make one complete wave, and can be calculated using the equation that's given to you in the exam, T equals 1 over F. If you struggle with this, just then contact me via Show My Homework, and I can perhaps guide you through it. But do make use of the online digital textbooks. That's also a good resource for you. Okay, until we speak again,